Hi guys, welcome to DST classes. In today's class, I will explain about a combinational circuit which is nothing but a comparator. So in design procedure of a combinational circuit, we have 4 steps. First one is identify the number of inputs and outputs and give letter symbols to the inputs and outputs. Second point is truth table. Draw the truth table which shows the relation between input and output. And third step is using K-map minimize the Boolean equations. So if we get the Boolean equation, and final stage is we have to draw the logic diagram. So now we are studying about DST. So after designing a logic diagram, we have to write the VHDL code for that circuit. Okay. So now we are going to study about comparator. What a comparator is, how many number of inputs and output, what is the relation between input and output. Let's see. So a comparator is a combinational logic circuit that compares two input levels and gives an output that indicates the relation between them. Right? Here we have two inputs and we have three outputs. Right? Two inputs and three outputs. So first output is an output that indicates if number A is greater than B, right? If A is greater than B, so this is the first condition. If A is greater than B, so we will get output in if the condition is satisfied. Second one is an output that indicates if it's smaller, means if second condition, if A is smaller than B, this is the condition. If A is 0, B is 1, so here A is less than B, then A is less than B is 1, remaining three condition output is 0. And finally an output that indicates the two numbers are equal. So if A equivalent to B, then we will get the third condition. So we will get A equal to B in two conditions. First one is if A is 0, B is 0. So when both the inputs are 0, 0, then this condition is satisfied. So here we have to place 1. So he sees the second combination 0, 1. Here A is less than B. So this one is 1. So coming to third one 1, 0. So here A is greater than 0. So A greater than B output is 1. And fourth one 1, 1. So it is A equivalent to B. So A equivalent to B output is 1. So for that we have to draw the logic diagram. So see A greater than B. So first for A is greater than B, so we will get A greater than B only one condition, and that condition is A equal to 1 and B equal to 1. So A equal to 1 and B equal to, what is the B? B equal to 0. So for this first condition, if we assume that A greater than B is 1, so F1 equal to A and B bar. So only this condition we will get output A greater than B. So that is the first one. If A, B bar, only one condition, we have to draw the AND gate. Okay na? Okay. And so next second one, A is, so here A is, sorry. So here, so second condition, in second condition we have to draw A less than B. So A less than B will happens. So when A equal to 0 and B equal to 1. So in this condition only A is less than B. This condition satisfied. So assume that this condition is F2. Then F2 equal to only one condition. So we dot production, which is nothing but A is 0. So A bar, B is 1. So B value is B. So this is the condition for F2. F2 is A less than B. Okay. So next third condition is A equivalent to B. A equivalent to B happens two times. So A equivalent to B happens two times when A equal to 0 and B equal to 0. Okay na? Okay. So when A equal to 0 and B equal to 0, or A equal to 1 and B equal to 1. So in these two conditions we will get A equivalent to B. So two condition we have to write F3 equal to, so A bar B bar, right, plus AB. Okay, so this is the third condition if A equivalent to B. So we can write this equation as A X NAR. So this is a symbol of X NAR dot circle. So A X NAR B. So this is the third condition. So this is first one is F1. So right, second gate is nothing but F2, and third gate is nothing but X NAR between A and B. So this is the logic diagram. So how we are designing a comparator means, so first bit is nothing but inputs. We have two inputs A comma B and two outputs. So first output is F1 and second output is F2 and third output is F3. Three outputs. So next truth table which shows the relation between input and output, and using this truth table also we can write, because it is very simple topic, a simple circuit. So without using any K-map we can write the Boolean equations also. So where F1 equal to A bar A B bar and F2 equal to A less than B means A bar B, and F3 equal to A X NAR B. So and fourth one is nothing but the logic diagram. So this is the logic diagram for a one bit comparator. So here 1 bit comparator means in A we have 1 bit and in B we have 1 bit. So we can compare these two numbers. So this is the logic diagram for 1 bit comparator. Okay. So I have written the equations also. So F1. So what is F1? F1 equal to A greater than B. So this is F1 and this is F2 and this is F3. Right? So what is F1? F1 equal to A B bar. So A value is 1, B value is 0. So next output is nothing but F2. So where A is less than B. So A bar B. So A value is 0, B value is 1. So next condition is F3. F3 is nothing but A bar B bar plus AB. So where both the inputs are same, 0, 0 and 1, 1. So for that we should draw the logic diagram. So this is F1. So F1. So this is second gate is nothing but F2 and third gate is nothing but F3. Right? So this is the logic diagram. This is the logic diagram for the 1 bit comparator. So this is how we design a 1 bit comparator. After designing a 1 bit comparator, next step is nothing but VHDL code. So what is a VHDL code? So very high speed integrated circuit hardware description language. So VHDL consists of two parts, entity part and architecture part. What is entity means? Which will give the information about inputs and outputs. So for number of inputs and how many number of outputs. Here we have 2 inputs and 3 outputs. So entity will give the information about inputs and outputs, whereas second one is nothing but architecture. Architecture will give the internal structure of the block diagram. So this is the VHDL code for 1 bit comparator. So see here, we have 2 inputs, A0 and B0. So A 2 inputs. So here, so A 2 inputs are nothing but A0 and A1, and we have 3 inputs, greater than, G stands for greater than, less than and equivalent to. So here all the 3 bits are only scalar types. So VHDL logic only. So end comparator. So architecture, begin process A. So process sensitivity list. Output is depends upon A. So we have to write in sensitivity list input variable. So input is nothing but A. So begin in starting stages, A greater than equal to 0, less than equal to 0, equivalent equal to 0. Right? So we are just initializing, means we will put zeros, reset state all the 3 outputs. Next, if A0 is less than A1, what happens? Here A is less than B. So L is equivalent to 1, less than equivalent to 1. Else, if it is not satisfied. If this condition is not satisfied, then we will go for the second. So what is the second condition? Else if A0 is greater than A1. If A0 is greater than A1, then greater than equivalent to 1. So remaining two outputs are 0, right? Else if these two conditions are not satisfied, then equivalent A equivalent to equivalent to E equivalent to 1. So this is the VHDL code for 1-bit comparator. So we can write the same program for 4-bit comparator also. So here we have to change only A. So here we have 3 bits, right? 4-bit comparator means here we have so if we take two inputs, so inputs are X and Y. So first input is X. So first input is X. So in X we have 3 inputs. So 4 inputs. So 4 inputs are X0 value, X1, X2 and X3. So in each number we have 4 bits. And coming to next input Y also we have 4 bit. So Y0, Y1, next Y2 and Y3. So we will compare two numbers X and Y. So previous circuit is 1-bit comparator, here n-bit comparator. So for example, I am writing a VHDL code for 4-bit comparator. Means in X we have 4 inputs, 4 bits, not inputs, bits. Okay, we have only two inputs X and Y. In each input we have number of bits, n number of bits. For suppose we are writing a code for 4-bit. So in these two inputs, in each input we have 4 bits. So X0 to X3, Y0 to Y3. So for comparison we will get only 3 outputs. If it is greater than number or less than or equivalent. So compare output is XTD logic vector 2 down to 0. So 3 out. So it's next process X comma Y. If A is greater than B, comparator is 1 0 0. Okay. So first is equivalent, greater than. If equivalent to 0 0 1, 0 1 0. If A is less than X, so comparator 0 0 1. In another condition, comparator is 1 1 1. So this is the VHDL code for 4-bit comparator. So this is how we can design a comparator. So a comparator will have 2 inputs and 3 outputs. A comma B are the inputs and 3 outputs are A greater than B, A less than B, A equivalent to B. According to that we have to write the VHDL code. Okay. So this is the how we can design the comparator and what is the VHDL code. So thank you so much. Next slide I will explain decoders and encoders. Thank you for watching.